Okay, so there should be a reason why the blockchain was created. I mean, anyone who creates a new invention or anything, that they always come up with that product only after they find some problem with the current situation. And that's when Satoshi Nakamoto created something called as the Bitcoin blockchain, which is nothing but a cryptocurrency. He was very sad to see the current financial system. He just realized that it was very centralized. Now if you go to a bank, you send your money, the money doesn't belong to you anymore, it belongs to the bank. You have no idea what's happening with the your money. And there's a lot of problems in the current banking system, which is why Satoshi Nakamoto thought, okay, we need a different system altogether, which is decentralized, which is distributed. So he came up with the concept of Bitcoin. So Bitcoin is just nothing but it's a cryptocurrency. It is just a use case of the blockchain. So we are only going to, we are mainly focusing on the underlying technology of Bitcoin, which is the blockchain. Now, Satoshi Nakamoto didn't like the current, system itself, which is why he came up with something like the Bitcoin blockchain. Now, for example, take the transaction fees for a normal banking system. You have a third party trusted entity like JP Morgan or the banks or any sort of bank. When you're trying to send money from one person to the other, for example, Chandler sending Joey some money. If he's sending $100, there's a transaction fee of $2, and Joey gets only $98. So there's that $2 might not be small. Means might be small for some of us, but then imagine, you know, if every one of us is spending that much money for just sending out transactions. And for example, JP Morgan Chase, Bank of America, and Wells Fargo almost earned 6 billion just from ATM and overdraft fees in 2015. So all this, like, it was not happy with the current situation and scenarios. If you remember the Great Recession, where 31%, the price fell by 31% for housing, and there was like 144.5 billion moved from money markets to treasure bonds and etc. All this actually created some sort of trigger in Satoshi Nakamoto, and he came up with the concept of blockchain. And there's also something called as double spending. Now, what is double spending? In the internet, if you send a file from one person to the other, you can duplicate it, correct? And that was the only thing stopping people from creating a system where money cannot be duplicated. And he came up with the concept of avoiding double spending by introducing distributed ledger technology. So how is actually Bitcoin solving these issues? Bitcoin solves this issue by it has a distributed ledger, so there is no centralized party involved who's going to take care of all your incoming and outgoing transactions. Then the ledger is public. Anyone can view any sort of transactions on the blockchain. Some of you must have heard that Bitcoin is anonymous, it's privacy, it's no one can track you, etc. The thing is, it is pseudo anonymous in the sense, when if you want to see you can actually track a transaction. When you send me money, I'll be able to make that transaction back to you, but I will not know your name, I will not know your address, I will not know anything else. There are ways to track a transaction by going to the exchange where it came from and figuring out who actually sent it. And also, transactions are immutable, thus cannot be hacked. Immutable is nothing but anything written on the blockchain cannot be erased, cannot be replaced, cannot be edited. Okay, now to understand how actually blockchain works and what exactly is block, um, you know uh, we should first of all understand how it actually works. Now, just let's take an example, a ledger, distributed ledger technology. Okay, now ledger is nothing but just a piece of sheet or an Excel sheet with incoming and outgoing transactions. So all, just imagine that's one particular ledger. In a centralized system, the ledger is owned by the central party, or the third party. They have control of this ledger and they can see all the transactions. But what is the difference between a blockchain is the ledger is distributed. This particular ledger is actually distributed between multiple nodes. So nodes, all these are like, imagine all of us are part of the network and we all are having a node. Node is nothing but just a system or a computer or a cell phone or a device which has a copy of this ledger. Now, for example, if James is sending 100 rupees to Kevin, that gets recorded in the blockchain in this particular ledger. And since everyone's got a copy of it, once this transaction goes through, it'll show up in everyone's record. Everyone will have that copy and it'll get updated that okay, James has sent this amount of money to Kevin. Okay, and who's actually looking at this transaction? There are special people called miners. So miners, just imagine Robert and Lisa are miners. What their job is to basically do is they're validating this transaction. So they'll check, okay, does James have that 500 rupees? Okay, he's got that 100 rupees. Is he sending to Kevin? Okay, looks like he's sending to Kevin, and they'll make sure that once he sends to Kevin, he should not have that 100 rupees with him, or he can't make that double spend, which is nothing but sending one transaction to Kevin and Steven, sending 100 rupees to Kevin and sending 100 rupees to Steven. That should not be possible. That's the job of the miners, and the miners are now no one but people who are actually take part in this network, and they validate the transaction, and they assure, okay, it looks like this is a valid transaction, and what they do is they update their ledger, and automatically everyone else is, they come to an agreement, consensus. So that's what is called as consensus. All of the miners and everyone come to a consensus stating, okay, this is a valid transaction and it can be added to the ledger. And the reason they as miners, the reason they take time and energy and spend a lot of money to validate that transaction is because they get paid in Bitcoin. So you should have heard about people talking about Bitcoin, but why? How is it exactly created? How is it made? This is how it's actually created. There are, the miners. They validate the transaction and they create this. Now, I want to show you what exactly is required for mining Bitcoin. You might have heard about people mining Bitcoin, and why, it's not a very easy thing. Initially, it was, and if you know the price of Bitcoin, when I started, it was 20,000, and now it's almost 9 lakhs. So there is a incentives based, so they get paid for mining, and it's a very huge process. It consumes a lot of electricity. It's environmentally not very friendly, and it works on proof of work concept, which is nothing but the miners are validating the transaction, and that's how they use this equipments. Now here is how it looks. I want to show you how people are actually mining for Bitcoin. So these are the kind of rigs or different mining equipments that is required for creating or generating Bitcoins. So graphical cards that you need, like huge amount of graphical cards, which will take a lot of electricity, and they'll you will be able to mine for cryptocurrencies. Now, why am I speaking about cryptocurrencies and why am I speaking about Bitcoin when we all want to talk about blockchain and the other use cases of blockchain? It is very important to understand why how the system actually works and why it was actually created, which is why I gave you guys an idea about how the transaction works. So Bitcoin is nothing but the first decentralized digital currency. It uses cryptography to control its creation and management, and it's created electronically. A ledger is produced by people using software that solves mathematical problem. So what exactly are the miners doing? They're solving mathematical problems to make sure that the transaction is a valid transaction, and they get benefited by getting cryptocurrencies, Bitcoin and any other coin for that matter. And you might have heard that blockchain is immutable, it's not hackable. You can't hack the blockchain, etc. The thing is, it is very difficult to hack the blockchain. It is possible to hack the blockchain, but it is very difficult, which I'll show you in a bit. Now, the reason it's very difficult to hack the blockchain itself is because one, it's immutable, and anything written on the blockchain cannot be replaced. Also, there is something called as a 51% attack. Okay, now to be able, no, if someone wants to hack the blockchain, if someone wants to make changes in a transaction, for example, if James is trying to send 100, he's trying to change his transaction to 10,000 rupees instead of 100, and he changes and he tries to send the transaction across, it is very unlikely that it will work. And if he wants to make that work, he has to control 51% of the nodes. The 51% of the people, he has to be able to control all of them, only after which, you must have heard about the recent in a story, and it already happened with another blockchain called ETC, which is a forked cryptocurrency of Ethereum. And what happened is, 51% of attack, if they can control it, they can make modifications in the blockchain. Now in the Bitcoin blockchain, it's almost impossible. Is why? It's because they'll need almost like 20, almost like $10 billion to make to control that 50% of the nodes, instead of which they can put that money into mining and they can make double the amount, so they can make a lot more money, which is doesn't make sense. So that's the reason they say blockchain is not hackable. So let's look at how a Bitcoin transaction actually works. So imagine this is the block. Now I'll tell you why it's actually called as a blockchain. It's just a chain of blocks. Now each block will contain a transaction. It will contain the ledger. It will contain the address from the person the money is going to, and the money that is coming from. So it contains the details of transfer of currency from one account to the other. It will have the balance, and it will also contain something called as a nonce. It will have a lot of data that is required in that particular transaction. And anytime the miners, they say, okay, this looks like a valid transaction, they add it to the block, and the block gets added to the blockchain. So that's why it's called blockchain. To understand how blockchain actually works, we also need to know cryptography. We have to understand now what exactly is cryptography. If you if anyone is familiar with cryptography, you will know that there are two types of cryptography. One is symmetric and asymmetric cryptography. So there's nothing, it's very simple to understand. Imagine A and B. Okay, A is trying to send a secret message to B. So what he does is he writes it in a readable format. He converts it. There's some sort of encryption that takes place, and it will come into a non-readable format. And that data is then moved to the person reading that message. And this person will be able to read that message using a specific or a particular key. Now, symmetric is nothing but, in the symmetric session, now for example, if A is trying to send a secret message to B, what he does is he locks that message using K1, and then he sends it to B. Now B can open that message using K1, and if D is sending another message like K4, B will have another key like K4, and he'll be able to open that message using that K4 key. In asymmetric cryptography, what happens is, a lab just to the problem with symmetric is, they'll have multiple keys. If you see, like, everyone sends a message, you'll get confused by which key I have to open each message with, which is very inconvenient. And what happens with asymmetric cryptography is, you have just two keys. One is the public key and the private key. So what A will do is, he'll have that secret message, he'll encrypt using the private key, sorry, the public key, and B will be able to open that message using his own private key. So he can lock it, and then he'll be able to open using the his own private key. So that's the difference between symmetric and an asymmetric cryptography.